Good morning, students. Today we are going to discuss the next three sums of the chapter Probability and exercise 15.1. The sums are sum number 7, 8, and 9. So, in sum number 7, the question goes like this: to know the opinion of a student about a subject statistics, a survey of 200 students was conducted. So the total frequency of total number of students, or the total frequency, is 200. The data is recorded in the following table. So the number of student liked statistics is 135 and the number of student disliked statistics is 65. We have to find the probability that the students chosen at a random likes statistics and does not like it. So let us see how to solve this sum. So the table that was provided is like this. Like statistics, number of student is 135, and dislike statistics, number of student is 65. So total we have 200. So total number of student is equals to 135 plus 65 is equals to 200. And number of student liking statistics is 135. So the probability of the event liking student, the one that we have written in the bracket, is our event. So the probability of the event that students liking statistics is 135 by 200. If we simplify it, we will get 27 by 40. So this is our subpart 1 of question number 7. Let us see subpart 2. In subpart 2, we had to find the event E, where the student dislikes statistics. So again, total number of student is 200 and number of student disliking or not liking statistics is 65. So the probability of a student not liking statistics is 65 by 200, the event occurring, and by total number of the students. So here 65 by 200. If we simplify, we will get 13 by 40. So this is our sum number 7, subpart 2. Now let us move on to sum number 8. In sum number 8, it says, refer to question number 2 of exercise 14.2. 14.2 is a statistics chapter. So we have to refer to that data that is given in this question number 2 of exercise 14.2. What is the empirical probability that an engineer lives less than 7 km from her workplace, more than 7 km from the workplace, within half kilometer from her workplace? So this is the data or the kilometer that occurs from the distance from the workplace to the home. So the 5, 3, 10, 20, these all are kilometers of individual engineers. So first we have to find less than 7 km from her workplace. So this was the data given. You can see all the bold numbers. If you see the first line, 5 and 3 are the numbers which are less than 7. So let us first mark the numbers which are less than 7. It is already done in bold. So 5 and 3. In the next line 2. The next slide or the third line we have 3, 5 and 3. Again the last line we have 2, 6 and 6. These are the numbers or the kilometers or the engineers whose distance from the workplace to home is less than 7. So how many are there? There are 9 in total. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So total number of engineers were 40. Number of engineers living less than 7 kilometers from their workplace, from the place to work, is 9. So the probability, the event that is occurring here, is the engineers who lives less than 7 kilometers. So probability of engineers lives less than 7 kilometer from her place of work is equals to the number of engineers living less than 7 kilometer by total number of engineers. So number of engineers is 9 and total number of engineers is 40. So our probability is 9 by 40. So this is our question number 8 subpart 1. Now question number 8 again is very important sum. Next question subpart 2 of question number 8 had asked for probability of engineers who lives more than 7 kilometers, more than or equal to 7 kilometers. So in the previous one, if you see the previous table only, the bolded one are the engineers is a kilometer which are less than 7 kilometers. So there were total of 40 engineers, out of which 9 engineers had their distance from their work to their place is less than 7. So if we subtract those 9, we will get 31 engineers who are living more than or equal to 7 kilometers. So if we see the table, the unbolded one are the engineers who lives 7 kilometer less or 7 kilometer more or equals to their distance. So let us, if we count them, you can see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31. So 31 are the engineers. So either we can see from the table or we can calculate like this. So total number of engineers is 40. Number of engineers living more than or equal to 7 kilometer is 40 minus 9. So we have 31. Hence the probability of engineers living less than 7 kilometer from their place of work is number of engineers by living more than, sorry, it will be not less than, more than. So here it also will be more than or equal to. Their workplace is 31 by 40. So we have our subpart 2. Now last subpart said that we have to find engineers who lives within half kilometers. Half kilometers means 0.5 kilometer. But here in our data, we do not find any decimal numbers or decimal kilometer. So there are no such event that is occurring. So total number of engineers is 40. Number of engineers living within half kilometer is 0, as there is no such engineers who lives within half kilometer from our raw data. So the probability will be 0 by 40. 0 by 40 means 0. So such an event is called impossible event. Impossible event. So this is our question number 8 subpart 3. Now let us see the last sum of today's discussion, that is sum number 9, which is an activity. So in an activity, the table or the data is assumed by each individual or us. So here the question said, note the frequency of two-wheelers and three-wheelers and four-wheelers going past during time interval in front of your school gate. Find the probability that any one of one out of the total vehicles that you have observed is a two-wheeler. So we have to find the probability that the number of two-wheelers passing your school gate. So here I have taken and values which I have assumed, that type of vehicles and frequencies. Type of vehicle is two-wheeler, three-wheeler and four-wheeler, and the number of times a two-wheeler or a three-wheeler or a four-wheeler passes, I have made frequency of it or number of times they went. This is my assumption. You can take your own assumption and do it. So two-wheelers is 150, three-wheelers is 25 and four-wheelers is 75. So now the total number of, we have to find the probability of two-wheelers. So total number of vehicles is 150 plus 25 plus 75 is 250. We have to find the probability of getting a two-wheeler passing, and that a two-wheeler passes is number of two-wheelers by total number. Number of two-wheelers is 150 and total number is 250. So we have the probability as 3 by 5. So this is our sum, three sums that we have discussed today, question number 7, 8 and activity 9. I hope this short tutorial